So let's look at solving with quadratic formula. This is quadratic formula. It solves for x. X equals negative b plus or minus square root of b squared minus 4ac, all divided by 2a. To use this equation, this formula, I have to substitute from a, b, and c from a standard form quadratic equation, where y is equal to 0. So first I have to have an equation that looks like this. Then I get my a, b, and c from here and substitute into the standard form, or into the quadratic formula. When I do that, I have three possibilities of solutions. I could have one solution, like if I solved this one. For this equation, a is 2, b is negative 4, and c is 2. So when I substitute into quadratic formula, it'll look like negative 4 plus or minus square root negative 4 squared. Make sure you use parentheses when you substitute, minus 4ac. This is all divided by 2a. So I've substituted. First thing I'm going to do is simplify this part under the radical. This part of my formula is called the discriminant. So let's do that first. You can put this whole thing into your calculator altogether. Let's see what this is. My discriminant is 0. So under the radical, I get 0. So this will be how my formula simplifies. Square root of 0 is 0. So I end up with just 4 over 4, which is 1. So x equals 1. This is my solution. When I graph this, I find that my x-intercept is 1. That's why when I solve it, my solution is 1. The x-intercept in the solution has the same meaning. So let's sketch that next to our problem. It doesn't have to be beautiful art. It just needs to be accurate enough to represent our problem. So here I have one solution. And you'll have one solution anytime your discriminant is 0. Let's look at another example. We're going to solve this one using quadratic formula as well. But I have a little bit of work to do before I can use quadratic formula because this equation is not in standard form and it doesn't equal 0. So I'll have to do some rearranging here. Okay, now I have a standard form quadratic equation set equal to 0, where a is 1, b is -3, c is -13. So I can substitute into my quadratic formula. And I'll simplify my discriminant. So I'll get, let's put this all in the calculator. $61. Actually, 61 is a prime number. I can't simplify that radical. Here's how you can check. Okay, to check, to determine whether a radical can be simplified, if you have a graphing calculator like this, you can type into y equals the number that you're trying to factor divided by x. And if you look at the table, oh, my table's set up differently. Now, when you divide by 0, it says error. So that's what I expected. But if I divide by 1, I get 61. Divide by 2, 30.5. Divide by 3, 4. I'm looking for a perfect square factor because I have to have a perfect square to be able to take the square root and get a whole number. So I don't have a perfect square factor for 61. That's because 61 is a prime number. But if you didn't know that, you can use this trick to check it. Do y equals then number divided by x, and then table to look at factors. Okay. I'm looking for something that I could take the square root of and get a whole number so that I could have a smaller number underneath the radical. However, for this one, that's not possible. So these are my two solutions. They're two solutions because I have x equals 3 plus square root of 61 over 2, and x equals 3 minus square root of 61 over 2. Those are my two solutions. When I graph this with two solutions, the graph looks like this. Where the two places that my the two places where my quadratic crosses the x-axis are not whole numbers. That's why I have a radical in my answer. So 5.405, and then also negative 2.405. Those are my solutions. So we can sketch this also. along with my problem. And what happens is anytime you have a discriminant that's a positive number, then you'll have two real number solutions. Sometimes they're pretty numbers, sometimes they're not, but either way, I get two places that my graph will cross the x-axis. One more example. We did a problem where you have one solution. We had a problem where you have two solutions, and then I'll do a problem where you have no real number solutions. Let's look at the graph first so that I can explain what you don't have a real number solution. This is what I'm talking about. So I'll go ahead and sketch it first this time. I mean, I don't have a place where my graph crosses the x-axis. So I'll go ahead and sketch that real quick. This is a standard form equation, but I have a missing b. So I'll write it as 8x squared plus b, 0x plus 1 equals 0. So a is 8, b is 0, c is 1. My equation's equal to 0. I can use quadratic formula. Okay, I'll simplify my discriminant. By putting the entire discriminant into the calculator. I got negative 32. And anytime that you take the square root of a negative number, you get an error. That's always been true. And the error is actually, error, non-real answer. The reason that it says non-real answer is that it's not a real number. It's an imaginary. So I have a new idea here. That we haven't had in math class before, which is negative 1 is a perfect square. Since you haven't ever had a number that you could square and get negative, let me show you how that works. On your calculator, right over the decimal sign is an I. I is a reserved number. It's not ever used as a decimal. Sorry, not ever used as a variable. Oh, my words are broken. But if you do second decimal, it'll put an I on your screen. And you can do I squared, and that's negative 1. So if I squared is negative 1, then square root of negative 1 has to be I. So this is kind of a big new thing. Let's use that to simplify our equation. I'm going to stop writing -0 because there's no negative, positive, or negative 0. It's just 0. So I just have 0 plus or minus the square root of -1 times the square root of 32 over 16. Square root of -1 is I, because I squared is -1. So I'll just take the negative out basically and write I instead. And then we want to simplify this radical. So I'll do y equals 32 divided by x table. And I'm looking for the biggest perfect square factor, which is 2 times 16. 16 is 4 squared. So I can write this as 16 times 2. That's helpful because I can take the square root of 16 and get a whole number. I'll leave the 2 under the radical. And I can simplify this equation because here I have a 4 and 16 is divisible by 4. So if I divide the numerator and the denominator by 4, then I get x equals plus or minus square root of 2 over 4. This is plus square root of 2 over 4 and minus square root of 2 over 4. Oh, I lost an I. Make sure you keep your I. I square root of 2 over 4 and negative I square root of 2 over 4. It's okay if you just leave it in a combination thing, because leave it as plus or minus, because you can't simplify this any further, so it's not necessary to split them into 2 pieces. But you can. This is correct if you list the 2, or this is correct if you leave it together. So because this curves at some imaginary place, I have 2 solutions. So what I get here is discriminant is a negative number. See, it was negative 32. And I have 2 imaginary solutions.